Hello everyone, in this video we will be solving problem 1493, longest subarray of ones after deleting one element. The problem statement is we are given a binary array nums. After deleting one element, we need to return the longest non-empty subarray containing ones in it. Please note that we absolutely have to delete one element from the array irrespective of its content. It could be a 0 or a 1. In example number 1, we have 1101 in the input array. If we remove the 0 in the center, we will get 3 elements in the subarray with 1s in it. Hence the output is 3. Similarly, if we remove the element at index 4, that is 0, we will get a subarray with 5 1s in it. I hope you are able to understand this straightforward problem statement. Let's switch to whiteboard and discuss potential ways of solving it. Like every other problem, this problem can also be solved using brute force. In this approach, we'll try to identify small segments of ones in the array and see which 0 should be removed from the input, which will give us the maximum subarray. For example, in the first iteration, we'll remove the 0 at index 2 and see what is the longest subarray we can get. After calculating the length, we'll repeat the cycle, but this time we'll try to remove a different 0. The challenging part with this approach is the duplicate calculation that we have to do every time we are removing a particular 0. It exponentially increases the time complexity, making this approach unusable. Now let's discuss if there is a better way of solving this problem. As we are looking for a subarray that matches a certain criteria, the most suitable algorithm is sliding window. Sliding window uses two pointers, left and right, where the right pointer is incremented whenever the criteria that you are looking for is sufficed, while the left pointer will be incremented when the condition is no longer satisfied. In other words, we increment the right pointer to expand the window as long as the criteria is satisfied and shorten the window by incrementing the left pointer whenever the criteria is not met. As the criteria for the subarray is to have all ones in it except for one element which can be deleted, we will make sure that the subarray or the window that we are looking for contains at max 1 0 in it. And whenever we stumble upon a second 0 in it, we'll start shrinking the window by incrementing the left pointer. Let's do a short dry run to understand this better. For the operation, we'll be using two pointers, left and right. The zeros will count the number of zeros in the window and the size of the subarray, while the max length will record the maximum length of the subarray that matches the criteria. Starting with both left and right pointer pointing at 0, the value is 1, which is a non-zero, so the 0 count will stay as 0 and the size will be 1. As the window criteria is satisfied, I'll try to expand the window by incrementing the right pointer. Right pointer is pointing at a non-zero element, so the number of zeros will stay as 0 and the size will be incremented to 2. I will repeat the same step of expanding the window by incrementing the right pointer. This time the right pointer is pointing at 0. As we are allowed to have 1 0 in our subarray, I will increment the 0 pointer by 1 and the size will stay at 2. As we don't want to include zeros in our subarray, I will not increment the size. After incrementing the right pointer again, the new value is 3. It is pointing at 1, which matches the criteria. So 0 will be staying as is, and I'll increment the size by 1. So the new value is 3. Every time we are incrementing the pointer and calculating the size, we'll be comparing it against the max length, and the higher value will be saved into the max length variable. We'll start with the default value as 0, and as 3 is higher, we'll save 3 into the max length variable. Moving on with the next value, where right pointer is pointing at 4, that is value 1. Number of zeros is 1 and the size is incremented to 4. As size is greater than the max length, I'll override the max length value by 4. After incrementing the right pointer by 1, the new value is 5. It is pointing at 0, incrementing the 0 counts to 2. As it breaks the criteria for the number of zeros in the subarray, we cannot use it. So now we need to stop incrementing the right pointer and instead increment the left pointer to shrink the window size. And this shrinking will continue until the criteria is met. That is, we only have 1 zeros in the entire subarray. As 0 is on index 2, we need to increment the left pointer twice to be able to meet the criteria. After incrementing the left pointer twice, the left pointer will be 2, the right pointer is 5, the number of zeros will be down to 1. With these values, the size of the window is 3. As the window criteria is sufficed, we can go ahead and increment the right pointer to expand the size. As the remaining elements in the subarray are all 1, we can include it into the subarray, giving us the total size of 5. With this solution, our time complexity is improved to O of n, as we are iterating through the input array once using the left and right pointer to identify the size of the subarray that matches the criteria. While the space complexity is O of 1, that is constant space, as we are only using a couple of variables to mark the left and the right side of the window and the maximum length of the subarray. I hope you are able to understand the explanation. Let me show you how we can implement this using Python. In this Python implementation, I've initialized 3 variables: the max length that will hold the maximum length of the subarray, the left pointer, and the number of zeros in the window. After that, I'm starting a for loop to iterate through all of the elements, and this pointer will be acting as the right pointer. If the right pointer is pointing at an element whose value is 0, I'll increment the 0 count variable by 1. If the 0 count is greater than 1, it means we breached the criteria, and now we need to start shrinking the window by incrementing the left pointer. This while loop will continue until the left pointer points an element whose value is 0. That's when we'll decrement the 0 count by 1, while the left pointer will be incremented every time. Once we know that the criteria is met and the window contains only non-zero elements except for 1, I'm calculating the length of the window, that is the right minus left, and comparing it with the max length, and whichever is higher is going to be saved back into this max length variable. Once the for loop is complete, I'm returning max length as the output. This code, when submitted on LeetCode, beats nearly 50% of the submissions in terms of runtime and 68% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.